In the previous lessons, we've been talking about functions. We talked about a relation, which was a set of ordered pairs, and then we talked about a function, which is a relation in which each x value corresponds to one and only one y value. And in the very most recent lesson, we actually looked at relations which were written as sets of ordered pairs, and we checked to see if they were indeed functions or not. In this lesson, we're going to use something to determine if a graph is a function. The name of this test we're going to use is the vertical line test. So sometimes I may abbreviate that VLT. If you think about a set of ordered pairs, suppose you have a point here, and a point here, and a point here, and a point here, and a point here. Each one of these points has a particular XY relationship. But you can tell because of the placement of the points that each X corresponds to one and only one point. It has one and only one Y value. So this set of ordered pairs represents a function. But if instead I had a collection of points like this, hopefully you can tell that for this point, its X has one and only one Y value. For this point, its X has one and only one Y value. But when you look at these two, they share the same X value. And I don't have a scale on here, but let's just say they have the X value of 1. Well, this one has a Y value. This one has a different Y value. This is not a function. And the vertical line test says if a vertical line would pass through two or more points, it is not a function because a vertical line is x equals some number. So if it touches this point and this point, then that x is corresponding to multiple y values. Use a vertical line. All right, let's look at our examples. The first one, use the vertical line test to determine whether the given graph is the graph of a function. Now, all graphs are relations. They are sets of ordered pairs. In my mind, I'm going to take a vertical line and I'm going to pass it. I'm going to go from left to right, but I'm going to visually pass it across the graph. Does the vertical line ever intersect the relation in more than one location? The answer is no. So for this x, there's one y. For this x, one y. This one, this one, this one, this one, this one, and all the ones that I didn't draw the vertical lines, a vertical line would only cross it once. So for each x, there's only one y. So this passes the vertical line test. The answer is yes, it's a function. Number 2. All right, once again, I'm going to use the vertical line test to determine whether the given graph is the graph of a function. If I draw a vertical line anywhere, you can see that it crosses my relation in two places. That means for that x value, there's a y up here and a y down here. For example, it might be, and I'm just kind of guessing, that might be the point -3, maybe 1, but it's also -3, -5. And please keep in mind that I'm just approximating what those points would be. But the x of -3 has more than one y value. Fails the vertical line test? No, it's not a function. All right, Is this line a function? Well, if I visualize vertical line from left to right in infinite number of vertical lines, you can see that it will never cross the graph more than once. Let me make those go away so you can see it again. No vertical line is going to hit it more than once. So this one passes. It is a function. Number 4, is this a function? Well, you can see that a vertical line could cross it twice. That means that that x has more than one y, and no, it is not a function. Number 5. All right, it passes, it passes, it passes, it passes, and right here, and in an infinite other locations, it fails, because for this x, there's 1, 2, 3 different y values. So no. And the thing is, if it fails the vertical line test anywhere, it fails. One failure, and it is not a function. All right, number 6. Vertical line. Now it seems to be passing right here because there's only one point, but the minute I get over here, for that x value, and remember, every vertical line represents x equals a number. So when x is equal to 3, you have a point up here and a point down here. No, it is not a function. So if a vertical line passes through the graph in more than one location, then it is not a function.